Alright, now for the question number 15 and 16. It has been derived from electromagnetic induction. A point charge q is moving in circular orbit of radius r with angular velocity omega, which behaves as a magnetic dipole. A uniform magnetic field along positive z-axis is switched on, that means perpendicular to the plane, which increases at constant rate from 0 to b in 1 second. That means it's increasing in a uniform rate. Assume radius to be constant. The application of magnetic field induces an EMF. It is known that for orbiting charge, magnetic moment is proportional to angular momentum, that we call as gyromagnetic ratio, but here it has been said with proportionality constant gamma. Now, the magnitude of induced field at an instant during time interval of magnetic field changes, you could go in this way: E into 2 pi r is minus pi r square dB by dt. But the question has says the magnitude, so therefore this would be plus. And question has additionally said that magnetic field has increased uniformly. So therefore this is going to be pi r square b by 1. And this gives us option number B. So therefore for question number 15, answer is B. Now let me go to question number 16, which is a nice application. It says that the change in magnetic moment. The question has said that magnetic moment is gamma times L, and this can be written as gamma m r square into omega, where m is the mass. Angular momentum I times omega. We require the change in magnetic moment at end of magnetic field change. That is what we have to see. So in this particular situation, you could see that dm is the change in magnetic moment, and that's going to be gamma m r square multiplied by d omega. And the change in angular velocity is all related to alpha. So quite obviously, we have been given for the time 1 second, so you can write dt, you can write dt, that's 1 second. And we know that E into 2 pi r minus is pi r square dB by dt 1. That has been seen from the previous question. And you could see that d omega by dt is alpha, which would be equals to QE by m multiplied by r. So that's force divided by mass is acceleration, acceleration by radius. And on all solving, you will land up with option number B. So the correct solution for question number 16 is answer B. Alright, let's go for question number 17, which is the matrix match. Here on list 1 we have alpha, beta plus fission and proton emission, and we got to choose this option. You could see that alpha decay quite obviously has any given nucleus X, A, Z would get converted to A minus 4, Z minus 2 plus helium 4-2. That's a characteristic of alpha decay, and that's exactly matching with option number 2. When it goes with beta decay, which is positron, the atomic number decreases by 1 and the mass number remains same, so there goes option number 1. For fission, it's a heavy nucleus splitting into middle width nuclei, and that goes for option number 4, and this is quite obviously the proton emission. So P goes to 2, Q goes to 1, R goes to 4, S goes to 3, there goes option number C. That means The question for answer number 17 would be C. Let's see question number 18 now.